Starting with the warm-ups, the first question asks you to find the value of x. So you're going to look at these two angles, these two lines here, whoops. These two lines here are parallel. So if they are parallel, then we know that these two angles, because they are cut by a transversal, are corresponding angles. And corresponding angles are congruent if the two lines right here are parallel. So we can say that x plus 20 equals 52. When I solve that equation, I minus 20 on both sides, and x equals 32. So if x equals 32, I can double check my answer by saying, well, 32 plus 20 equals 52, and they both equal 52. Number 2, how do you know that this is true? How do I know that angle 3 is is congruent to angle 6? Well, I know that if I have two parallel lines cut by a transversal, then I have alternate interior angles. And alternate interior angles are congruent if you have parallel lines. So these are alternate interior angles. I'll erase that. Oh, shoot. Let's just go to a different color. Number 2, angle 4 and angle 6 are supplementary. So angle 4 right here and angle 6, they're saying that they equal 180. And this is true because with the parallel lines, these two are parallel, cut by a transversal, then we have consecutive interior angles. So angle 4 and angle 6 are consecutive interior, which means that they are supplementary. So consecutive interior angles. Number 3, if angle 2 is 115, find the measure of angle 7. Well, I know that because these two are parallel, cut by a transversal, then angle 2 and angle 7 are alternate exterior angles. So that means that angle 7, the measure of angle 7, also equals 115. Now moving on to the postulates. I'll move this up a little bit here. And we have 4 postulates. If two lines are cut by a transversal, so we're going to start with corresponding angles are congruent, then the lines are parallel. So what we're saying is if we have corresponding angles like angle 2 and angle 6 and they're congruent, then we know that M is parallel to N. If, moving to the right, if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So if we say that the alternate interior angles, like angle 4 and angle 5, if they are congruent, then M is parallel to N. I could also say if 3 and 6 are congruent, then M is parallel to N. So 3 right here and 6 right there, because they are also alternate interior angles. Moving down to the left, if two lines are cut by a transversal, so the alternate exterior angles are congruent, then lines are parallel. So if I would say that angle 2 and angle 7 are congruent, or I could also say if angle 1 and angle 8 are congruent, then M is parallel to N. If two lines are cut by a transversal, so the consecutive interior angles are supplementary. That's a new one. They're not congruent. They're supplementary. Then lines are parallel. So if we have angle 4 right here and angle 6 right here, so 4 and 6, if they equal 180, then we know that M is parallel to N. And that goes for also on the left side, 3 and 5. If they are supplementary, then M is congruent to, or M is parallel to N. Okay, on the back side, we're trying to prove that lines A and B are parallel, and we need to look at them. If we can prove that one of the 4 angles are congruent, 4 types of special angles are congruent, then we know that the lines are parallel. So we look at these lines, we have two lines going in the same direction, and we have them cut by a transversal. That means that if these 2 angles are one alternate interior, alternate exterior, consecutive interior, or corresponding, then those 2 lines A and B are parallel. So looking at these 2, we have this angle and this angle would be alternate exteriors, so yes, they are parallel because we have alternate exterior angles that are congruent. Looking at example B, we have parallel lines cut by transversal, and these 2 angles that are marked congruent are called corresponding angles. And they are congruent, so that means yes, because corresponding angles are congruent. Looking at the third example, we have angle 1 and angle 2. Again, we have these 2 lines cut by transversal, and these 2 are alternate interior angles. Alternate interior. And I know that alternate interior angles are congruent. Therefore, this would be a no because alternate interior angles should be congruent. So alternate interior angles need to be congruent. They could be the same measure, but it's not marked, so we can't prove that the 2 lines are parallel. Okay, moving on to the last part of the notes. Find the value of x that would make the lines parallel. So if these 2 angles are congruent, then these 2 lines are parallel. So I would have to find the value of x by saying 3x plus 15 equals 75. And I get that because these 2 are alternate exterior angles, and alternate exterior angles are congruent. So minus 15 on both sides. So 3x equals 60. Divide by 3, and x would have to equal 20 for those 2 lines to be parallel. Move into example 2. I know that these are consecutive interior angles. They're on the same side of the transversal, and they're interior, so these 2 equal 180. So I combine like terms over here, so I have 8x plus 16 equals 180. Subtract 16. 8x equals 164. I divide by 8, and x equals 20.5. So in order for those 2 lines, these 2 lines to be parallel, x has to equal 20.5. And move into the last example. These 2 are on the same side of the transversal, so they are corresponding. And I know that corresponding angles are congruent to each other. So I would minus 2x on both sides, or get my x's on the same side. So I have 3 over here equals 6x plus 9. subtract 9 on both sides, and I get negative 6 equals 6x, divide by 6, divide by 6, and x equals negative 1. So again, in order for those two lines to be parallel, these two lines to be parallel, x would have to equal negative 1.